Hey guys, welcome back to my channel and I hope you are all doing extremely well. This is lecture 20 on my linked list series. So far I covered 19 lectures and I highly recommend you to please start watching from lecture 1 till whatever I'm going to post in future. And I believe that at the end of this series you will be in a position to crack any linked list based question in an interview. Without further delay, let's get into today's lecture. In this video, we are going to solve one more lead code medium problem. The problem number is 86. It is all about partition list. Let's try to understand the problem statement. We will be given one linked list along with an X value. The ultimate goal is we need to segregate this list. We need to partition this list such a way all the values which are lesser than the X should appear in the first half and all the values which are greater than or equal should appear in the second half. Okay, let's go to our diagram and try to understand in much better way. If my list is of like this, 1, 2, 3, 4, 3, 2, 1 and once next is null and my x is 3. If you carefully observe what are the values which are greater than or equal to x, this one and this one, right? We need to return output something like this 1, 2, this 2 should connect to this one, 2 and 1 and followed by this 3, 4, 3 and 3 next is going to be null. This is how we need to return our output. And here the key point is, if you carefully look at the problem statement, you should preserve the original relative order of the nodes in each of the two partitions. That means you are not supposed to return something like this 1, 2, 1, 2, and then 3, 3, 4, and 4 next is null. Here also we can see the first half is or less than or equal to x, and this second half is greater than or equal to x, but this is not the valid output because we are changing the relative order of the nodes. Okay, that's all for the problem statement and I hope you understood. Let's try to understand how we can solve this one. Okay, let me take the new pen. If my list is of like this, let me go and take the same input 143252. Okay, it's is 142352. 2's next is null and x is 3. What I'm going to do here is I'm going to take a small header, something like this, and the high header. Okay, I will tell you why I'm taking this. So initially these are going to have the minus 1 nodes. Then I'm going to have my head here. Every time what I'm going to check is if my head is less than x, is my 1 is less than x, that is 3. Yes, if this is the case, then I am going to link that to the my small header. Okay, then small header next is going to be our current head. Then I am going to move my head to the head dot next. Again I will check is my x, is my value 4 is less than x? No. Then I am going to link that to my high header. So that is going to hold 4. Then I am going to move my header to next. Then 2 is 2 less than or sorry less than 3? Yes. Then it is going to be a part of this chain. Then my head is going to be at next. Is 3 less than 3? No. Then it is going to be part of this one. Then my head is going to be at here. 5. Is 5 less than 3? No. Then it is going to be a part of this chain. Next, my head is going to be at here. 2. Is 2 less than 3? Yes. Then 2 is going to part of this one. Now head is pointing to null. So when we reach where head is pointing to null, then we can terminate the complete loop. We come out of that loop. Now you can see your header, small header has 1, 2, 2 and your high header has 4, 3, 5. Ignore this minus ones. Then your small header next is should point to this one. And since every list last node should point to the next, that means a null, then give this as a null. That means 5's next is null. So that's all for this approach. Okay, so what we are essentially doing is, so we are taking to list and we are making the chain of the nodes. Okay, if one node value is less than the x, then we are forming that to the small header. If one node value is greater than or equal to the x, then we are forming chain to the next list. So that at the end of this list and this complete iteration, we are going to have this two list, and you can link this like this. Your small header dot next is equals to head high header dot next. That's all. So let's try to understand the time and space complexity. The time complexity is going to be big of n because you are going to iterate through the list only once. Okay. The space complexity is going to be big of n because we are not creating the nodes every time. We are just using the links to have to form the chain. Okay. So that is the reason behind big of one time complexity. That's all for the explanation. Let's go to the coding and try to solve this one. So the base condition is if, let me zoom this a bit here, yeah. If my head is equal to null, or my head dot next is null, that means there might be a chance of having no nodes or else only one node. So if there is only one node, then it might be lesser or greater, but you need to return the as it is output. So just return your head. And then what I'm going to do here is list node smaller head is equal to new list node of, you can create with any value. I am comfortable with going with 101 minus. You can take any value when you can take 0 or else anything. Okay. Then the next is higher head, that is going to be new list node of minus 101. I'm done. So now I need a two pointers which should point to the head node, I mean smaller header and higher header, right? So for that, list node small is equal to smaller head, then list node high is equal to higher head. Okay. Now let's try to start iterating from the head. So while head not equal to null till this condition satisfies, then what I'm going to do here is I'm going to have the if condition. If head dot val, if val is less than x, okay. In this case, what I need to do, I need to point my head to the small dot next, right? So just do small dot next is going to be your head, then your small is equal to small dot next. That's it. What if the value is greater than or equal to the x? In that case, you just need high dot next is going to be your head, then high is equals to high dot next. That's it. At the end of this if and else, you need to move your head by one position forward. That is head equal to head dot next. You are done. So at the end of this, okay, what you need to do? So your high next should point to the null, right? That's what I said here. Here you can see your 5 next should be null because that is last node in the list. So for that, high dot next is equal to null, and then you need to do what? Your small dot next is going to be your higher head dot next. That means this 4. Okay, we are doing higher head dot next because we want to ignore this one minus 1. Okay, here in this case minus 101 we need to ignore. For that, just do small dot next is equal to, what is this, higher head dot next. That's all. So at the end, just return smaller header dot next, so that it can skip that minus 101 node which we created. That's all. Just give a run. Yeah, it got ran. Let's submit it. Yeah, it got submitted successfully. It took 1 milliseconds. So that's all for this video, and I hope you learned something new today. Please do subscribe to my channel, and I'm going to post more valuable content in the future so that you can able to learn the things in much better way. Don't forget to tap the bell icon also because you are going to get the updates whenever I upload a new video. That's all. Thanks a lot. Bye bye.